So they're using the parent function as a guide, and they graph the parent function for you. So you can pick points off of that and use that when you get to the graphing part. How are we at the transformations? Do we know what those are right away? Yep, vertical stretch by factor of 2. Good, and then the second one is a horizontal translation, 4 units square. Okay, 4 units long. So we have those two things. Now, this is also, when you're graphing, it didn't tell you here to find the asymptotes, but that is part of your graph. So using what we know, the vertical asymptote is going to be x equals what? -4. Okay, the horizontal asymptote is your k value, right? So this is like +0. So your horizontal asymptote is going to be y equals 0. You could also think of it as the degree, right? The degree of the numerator, in this case, is less than the degree of the denominator. So doesn't that also produce y equals 0? So either way you thought of it, you should be getting that there. So let's go ahead and graph that. Again, graphing these is going to help divide it into those 4 quadrants, and then we're going to label x equals -4, and then the y equals 0. So just, you can put it a little bit above, or I said try to use a color, and then we're just going to be labeling it as y equals 0. Okay, so this already gets us in the right direction. Now, when we did our notes, what we did is we just took the parent function and then we made the application of the vertical stretch and the horizontal transformation. Okay? The points that we used for y equals x were 1, 1, 2, 1/2, and then 1/2, 2. And that's just by plugging things in. So if you were trying to make a graph for that, let me put this on the sticky. If you were trying to look at your graph for f of x equals 1 over x, the parent function, remember, all I did is pick values for x that were simple to compute. So if I picked 1, 1 divided by 1 is 1. If I picked 2, 1 over 2 is 1/2. And then I just did the reverse. 1 divided by 1/2 is going to be 2. And then remember the thing we also talked about? 1 times 1 is 1. 2 times 1/2 is 1. 1/2 times 2 is 1. Okay? And then we did the same thing, but with the negative values. So if I plug in -1, I get -1. If I plug in -2, I get -1/2. If I plug in -1/2, I get -2. Okay, so this is the parent function. If I want to transform it for my g of x, okay, you can use your table, that is perfectly fine. You can also use this. If it's a vertical stretch by a factor of 2, what happens to the y's? Or I should have made you tell me. If it's a vertical stretch, you apply it to the y's, right? So the vertical stretch means you multiply all the y's by 2. You multiply them all by 2. Same thing with these. Multiply them all by 2 times 2.
Can I do those in the calculator too?
Yeah. Yeah. And then if you multiply by 2, you get 2, 1, 4. Now, with the horizontal translation, 4 units left, what does that mean for the x's? What do I do? Just subtract 4 from all of them. So for the x's, you're going to minus 4 because that's left. You're going to minus 4 because that's left. So 1 minus 4 is -3. 2 minus 4 is -2. 1/2 minus 4 is -3.5. Okay, and then this would be -5, -6, -4.5. Okay, So you could do it that way, or you can also graph this in your calculator. So this would be 2 divided by, and then you have to put this part in parentheses, the x plus 4. Okay, and then let's look at our values. Look, -3, 2, -2, 1. We didn't put in -1, that's okay. We didn't put in 0, that's okay. So the table is just going to give you more points that you can substitute in, and that is fine. Okay, so if you look at -10, -0.3 is -1/3. Okay, at -8 you have -0.5. And notice that they're going by 2's. So this would be your 0.5. And then at -6, I'm at, oops, what'd I do wrong? What'd I do wrong there? It's an easy thing to mess up. What'd I do? I put it on the positive side. We want it on the negative, right? And then -5, -2, and then at -4 we have an error. But remember, we know the shape of this, right? It's going to follow this line, and you're going to put your arrow there. You're going to put your arrow there. Okay, and then we're going to create the other branch, which is really part of what I have here. So at -3, I'm at +2. At -2, I'm at +1. At 0, I'm at 1/2. And then again, once you have those points that create that curve, we know exactly where it's going. Okay, and then one other thing you're going to have to know how to do is the domain and range, which you did for these below. Okay, just remember when you do your domain and range, your domain is always going to be all real numbers except for that vertical asymptote, and your range is going to be all real numbers except for that horizontal asymptote. Which way do you guys like better? Do you guys like doing the table with the transformations? Do you feel more comfortable using the table on your calculator? Mm-hmm. Yeah, you mean just make the table that I used on the calculator? Oh yeah, just these? Yeah, of course. Yes, yes. Yeah, so they already put the 1/x in there for you. Okay, I won't be putting that in there for you. You'll just be graphing your new function. Mm-hmm.
So on the test, you can use the calculator?
Yes. Yep. So this is the calculator permitted portion. So 5-4, you'll be able to use your calculator for that. Absolutely. Mm-hmm.
So then the test without the calculator is only on 5-5 and 5-6.
Right. Exactly. Yep. So this whole front page, you'll be able to use your calculator on now. All right. And then let's go over the next one. So if it's x minus 3, that means your asymptote vertical is going to be x equals 3. Yes, you have to say x equals. Okay, it's that and y equals 5. And then your domain and range have to be in the set builder notation. So x such that x cannot be 3. And your range is going to be y such that y cannot be 5. Okay, and then a similar process here. So your x, this is always taking, you can think of it as your denominator equal to 0, and then solving. And then the 1 and the 5 on the outside, that's going to be your y. Now don't forget the negative here. And then your domain is x, such that x cannot be -8. because that would produce a 0. And then your range is y, such that y cannot be negative 1. All right, and then the next one, you do have to make sure that you factor that. I'm going to show you guys mine for that. Okay, so you're going to factor the numerator. The denominator does not need to be factored. And to find the zeros, we already talked about this today. You set your numerator equal to 0 and solve. So when you set this numerator equal to 0, you get two answers. X equals -5 and x equals 1. So when you do that, okay, these are your x-intercepts. This is what I plotted. Once I get -5, 0, I put that on my graph. Once I get 1, 0, I put that on my graph. And then the vertical asymptote, x equals -1. Okay, I have a dashed line at -1. And then the horizontal asymptote, you have to compare the degrees. In this case, the degree of the numerator is 2. The degree of the denominator is 1. Because the numerator is greater than the denominator, the rule is that there is no horizontal asymptote. So you can write none, you can write no horizontal asymptote. Either one of those are fine. Okay, and then when you are finding the domain is x, all remembers x, such that x cannot be -1, and then the range. If there is no horizontal asymptote, there are no restrictions on the range. So it's all real numbers. So this is how you say that in set builder notation. Y such that y is an element in the set of real numbers. Okay? And then again, this is one where I use my table. So when you're plugging this in, again, if you haven't practiced this on your homework, it is very easy to get the parentheses mixed up here and forget them. So you really need to make sure that you do some of that practice, okay, that you're checking those to make sure, okay? And then so here's my function. Those look pretty good. And then again, I'm just using my table. So your table, your graph is going to be given to you. So I know I'm just going from -10 to 10. So I'm just plotting these points on my grid. I should already have the -5 and the 1. Okay, and then I'm connecting them with that curve. And obviously you'll be able to graph it and see the shape of it. You just have to pick specific points to put on your graph. Okay, can you think of some questions you have about the graphing part? So that is the part where you get your graphing calculator. Mm-hmm.
Do we need to have a table?
Yeah, it's likely going to say that you're going to have a table with a certain number of points on it.
Can we just copy the table from our calculator?
Yeah. Mm-hmm. Yep. All right, and then the last one where you had to solve, it was asking you what the asymptote is and what it represented. So there is a horizontal asymptote at 250. Because the degrees are equal, it would be 250 over 1, which is 250. Then to figure out what that means, just go to what they said the function is, right? So instead of y equals, this is n, because it stands for the number of daily visitors to a new store. So that means that 250 is the average number of visitors to that store per day, okay, or on a daily basis. So you're just applying it to this situation. There's also a horizontal asymptote, which is at x equals 0, because x is the number of days the store has been open. So you can't calculate the number of daily visitors if the store is not open. Okay, that's why that will not be part of your domain. And then to find how many visitors can be expected on day 30, you'll just substitute that into your function, and then solve. And then you're just rounding to the nearest whole number, which was 283.